I've been looking at quicksort algorithm. So I'm trying to implement this algorithm for my web application. It's just for you know uh, just for me to learn what is quicksort and how do I can implement this. But in this video, I think I'm just going to uh, probably just you know go through this article and trying to understand what it's all about. And then in the next video, we're gonna basically, you know, try to implement this algorithm. So, what is quicksort algorithm? It's a sorting algorithm, where if you got an index of elements, a series of numbers, typically, so you try to sort them in descending or ascending order and in an orderly manner. So it's a sorting algorithm based on the divide and conquer. So what is divide and conquer? So it's just trying to say that uh, this algorithm uh, is a recursive implementation. That's on a high level, but what is it trying to say is just that we will repeat this algorithm. We have like a similar way of sorting the elements, if that makes sense. So you try to basically just decompose the problems into a smaller but more manageable. Try to make it easier. Okay, that's all I have. I understand. I do have looked through this algorithm, and it's basically just you've got a pivot. So there's a notion of a pivot and partitioning. That's like one of the two key concepts in this algorithm. Yep. Oh, and it says here works on the principle of divide and conquer, breaking down the problems into smaller sub problems. So there are mainly three steps in the algorithm. So you need to select a pivot, select an element from the array as the pivot. The choice of pivot can vary. First element, last element, random, or you take the median, which is like the middle element in the unsorted array, and then you just compare it with like usually from the leftmost index, the leftmost element with the partition. Yeah. So you partition the array, rearrange the array around the pivot. Yep. After the partitioning, all elements smaller than the pivot will be on its left, and all elements greater than the pivot will be on its right. So with this algorithm, and from this second point here, I think what it's trying to say is that selecting the median as the pivot is more, I would say, optimal in most case because, like I said, I think it's more manageable. If I It is more manageable in a sense that I would say that you could sort the elements on the left. I mean, like all the elements that is smaller is gonna be sorted. Okay. How do I say this? Let's say if I select the rightmost element, which is like the rightmost element of the array, for example, like 6 here. So that means I have to compare like every single one of these, and it'll take some time. I guess yeah, that's what I'm trying to say. Okay, and then recursively call. So recursively apply the same process to the two partition subarrays, left and right of the pivot. Base case, the recursion starts when there's only one element left in the subarray, as a single element is already sorted. So yeah, the base case here means uh, this I think is like the most, I would say it's the O of one. If that makes sense. Well, the statement here says that if there's only one element left, so I would say that um, there's only one element that is out of order. If that makes sense. So if I can show you here, so for example, you got 1, 2, 4, 3 as this element. So the base case is you just need to sort 3 and 4 to the correct position, and yeah, I think that's about it. Yeah, choice of pivot. Yeah, always pick the first or the last element as pivot. There are many different choices. Okay, the below implementation picks the last element as pivot. Okay, I think we should start with this one first. Sorry, ADHD. No. Here we have representative call. Okay, so we're selecting 5 as the pivot. So then I would say, recursively compare it. So let's say we start with 4 and 5. So you want to ensure that, okay, so when you compare 4 and 5, so that means you can move up to the next. So you just switch this to, I think. Not really sure. So yeah, pick the median element as the pivot. This is an ideal approach. Yep, I guess my intuition was correct. God, I should have my intuition back in exams, but it's never there. So partition algorithm. The key process in quicksort is a partition. There are 3 common algorithms to partition. All these algorithms have O of n time complexity. Here we create a copy of the array. First put all the arrays back into elements. Put all the smaller and then all the greater. Then we copy. Yeah, fuse this. Actually, I don't know what this means. Let me just try to comprehend. Here we create a copy of the array. First put all the smaller elements, then all the greater. Finally, we copy the temporary array. So how do you put the smaller elements first and then all the greater? So I guess it's based on the pivot, I suppose. So I suppose this is like the naive approach, like from this partitioning here. This is the naive partitioning. Then pick a random element. This is perfect because it doesn't have for which the worst case happens. I wouldn't say that. Sorry. Lomuto. We have used this partition in this article. This is a simple argument. We keep track of keep track of index. Okay, so the keyword is index of smaller elements and keep swapping. We have used this because it's of its simplicity. Huh. I'm trying to understand this one first. Then all the greater. Finally, we copy the temporary array back to original array. So I guess you put this in extra array. So then you try to compare. So you put this as a copy, store this as a copy, this list here. So then you're trying to compare with what? Like, I would say, copy the temporary array back to the original. Huh. Maybe it's just best if we can take a look from here. Yeah, I do love Edge, by the way. They have this split screen window. thing here. Okay, so naive partition algorithm given an array that has the version array by assuming the last element is pivot element. Okay, so for this case, you need to select the rightmost element in the array as the pivot. A partition of an array must satisfy the following two conditions: element smaller than or equal to the pivot element appears before pivot in the array. Note there might be more than one possible partition arrays. Naive approach to partition array. A simple approach to partition an array is to create a new temporary array which will store the rearranged elements. We first iterate over the original array. So let's say we iterate all this and add all the elements that are smaller or equal to the temporary array. So that means values that are less than or equal to 6 is we're going to put that. So that means we're trying to put 5, 2, 1, 3, 4 here into a smaller array, to a temporary array, sorry. Then we add the pivot element to the temporary array. So what it's trying to say is that finally we fill, then we add the pivot element to the temporary array. So I'm not sure where the position. It says here you put the pivot, so 6 into the temporary array. In our case, we put the 6, but I'm not too sure which position. So since we add, I think I'm just gonna assume it adds to the to the leftmost. To the rightmost value. Yeah, it adds 6 is going to be at the rightmost in the new temporary array. Finally, we filled the remaining part of the temporary array with elements that are greater than the pivot. Then we add the... Finally, we fill the remaining part temporary array with elements that are greater than the pivot. This ensures that the small elements come before the pivot and the larger elements come after it. Now copy the elements. I guess, yeah. Before we can proceed with quicksort algorithm, I think we can start to implement this naive approach. Yeah. I like to be meticulous about all the small details. I'm that picky because I want to learn. So this would be a good opportunity for us to learn. So I think we'll stop here and we'll pick this up in the next part of the video.